Assalamu alaikum. Bismillahirrahmanirrahim. Rabbi shrah sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi zidni ilma. How is everyone? Hope that you all are learning, enjoying your learning. Okay, today we are going to solve one more paper, that is Computer Science Paper 1, Computer Systems, 0478 Paper 11, October, November 2023. The duration of the paper is 1 hour 45 minutes. You have to answer on the question paper and no additional materials are needed. And a few instructions, as we all already know, but let's recall. You have to answer all the questions, use a black or a dark blue pen. You are allowed to use HB pencil for any diagrams. You have to write your answer to each question in the given space. Do not use an erasable pen or a correction fluid at all. Do not write on any barcodes. Calculators must not be used in the paper, so please do not carry the calculators to the examination hall. The paper is of 75 marks. The number of marks for each question or part question are given in brackets. There's no mark awarded in case you are using the brand name, so please refrain from using the brand name. Let's start. Question number 1. A student uses a computer and several hardware devices to complete his schoolwork. The computer has a central processing unit. Part A. The student uses a keyboard to complete his schoolwork. Tick one box to show which type of device the keyboard is. Do we all know? Yes, I think we all know it, isn't it? The input device is your keyboard, isn't it? Now, part B. The student uses a printer to print his schoolwork. Tick one box to show which type of device the printer is. Input, memory, output, or storage. Exactly, input was keyboard and printer is the output device. So in this manner, for part A, the answer is input, like again part A. And for part B, the correct answer is part C. And in this manner, you have ticked the right option and 1 and 1. 2 marks are yours. Easy? Yes, exactly. You all have done it. That's really very great. Now let's move to the next question. Now part C. A component in the CPU sends signal to manage the fetch, decode, execute cycle. State the name of this component. So inside the CPU, it's a control unit. So you have written this answer correctly. You are going to score 1 out of 1. Part D. The CPU has a clock speed of 2.5 gigahertz. Describe what is meant by a 2.4 gigahertz clock speed. It's a 2-mark question. So how will you score 2 out of 2? You can see the CPU is going to complete 2.4 billion cycles per second, or you can say the CPU completes 2.4 billion clock pulses per second. And in this manner, you will be scoring 2 out of 2. 2.4 billion and cycles per second or clock pulses per second. Now, part E. The CPU contains registers including MAR, and including the memory data register MDR. Describe the role of MDR in the fetch, decode, execute cycle. So what is MDR doing? It stores data exactly like you know that MDR, as name implies, is for storing the data. So the word D for data is actually denoting the purpose of this MDR, isn't it? And here you can see, what is the role of MDR? It stores data that has been fetched to or to be written to the memory. So in this manner, if you've talked about the storage of data and which data that has been fetched from or to be written to the memory, then you will be able to score 2 out of 2. Isn't it easy? Okay, now part 2. E1 was the explanation of the role of MDR, and part 2 for this like E2 is identify 3 other registers contained in the CPU. Now they are asking about any 3 registers. So MDR is mentioned. So what is left is MAR or memory address register, program counter or PC, current instruction register or CIR, and accumulator or ACC. By the way, if you know the full forms well, then fine, go ahead with that. But if you think that you do not know the spelling, or maybe you do not, you're not confident about the full form, then suggestion is use the short forms. That's perfectly okay to use MAR, PC, CIR, or ACC, and any three from the registers mentioned can be written to gain 3 out of 3 here. Any questions till now? Okay, question number 2. A car park has a payment machine that allows a customer to pay for the parking. The cost of parking is displayed as a Denary number on a screen on the payment machine. The cost of parking is stored in two 8-bit binary registers. For the parking cost of $10.50, register 1 stores the Denary value 10 as binary, and register 2 stores the Denary value 50 as binary. So this 10.50 is actually broken into two components, as you can see here. It's 10 to be denoted as a binary value, and it's 50 to be denoted as a binary value also. Fine. So this is your division. Now, what is the question saying? Give the parking cost that would be displayed on the payment machine when the register store, register 1, register 2, and parking cost is displayed as. Now, this is basically your working space, and you have to just mention that what is it actually. So what is supposed to be done? Working space is to be used, like they have told, this is an example, and give the parking cost that would be displayed on the payment machine when the register store this. Register 1 is storing this data and register 2 is storing this data. So what you are supposed to do is you have to work on register 1 components, the contents, and register 2 contents. By the way, we know we are starting from the right hand side, and we know the LSB 1, 2, 4, 8, 16, 32, 64, 128. And we wrote the values, like I wrote 1 here, then 0, then 0, and then 0, and then 1 again, and then 3 zeros. So just see which bits are on. Bits 16, bits representing 16 and 1 are on. They are added, and we got the value of 17. So parking cost for register 1 was 17. Okay, this is your parking cost to be displayed here. Now moving to the register 2. As you can see, register 2 is 0100 and 0110. So if we just utilize the same technique as we have done, it's 1, 2, 4, 8, 16, 32, 64, 128 for the byte. And you can see here 0110 and 0010. And then you can see you are simply going to add, and what you obtain is 64 plus 4 plus 2, that gives you 70. So in this manner, the parking cost is basically 17.70, which we obtained from register 1 from here and register 2 from here. So in this manner, once you have got the values, you have put them in the right like working, and you've obtained the right answer as 17 for register 1 and 7070 for register 2, and this is your final answer. Any questions? See, it's so simple. Just simply a 2-mark question, register 1. If you have found the value correctly, you are going to score 1. If you have found the value for register 2 also correctly, then another 1, and that will give you 2 out of 2. Any questions? Okay, fine. That's great. Maybe move ahead. Okay, now part B. The parking cost of $14.98 is displayed on the payment machine. Give the 8-bit binary numbers that are stored in the registers to display the parking cost. So register 1 is 14, as we can obtain from here, and register 2 is 98, as we can obtain from here. So simply placing the ones or zeros in the right position to get the value for 14. And I hope that we remember it very clearly, that it's going to be 8421, as you can see here, and 8421, and then 16, 32, 64, 128. So basically 8, 4, and 2 makes it 14. So you have turned on these bits and you got the answer for 14. And for 98, again, I hope that you remember, we have been learning this. The 64 and 32 added give you 96. So now what is left is 98. And for that, like for to complete the 98 value, you have turned on this 2. And in this manner, when you add 64 plus 32 plus 2 gives you 98. So in this manner, what we obtained was for 14, it was 0, 0, 0, 0, 1, 1, 1, 0. And for 98, we got 0, 1, 1, 0, 0, 0, 1, 0. And these were written in their respective registers, and you again scored 2 out of 2. Easy? Any questions? Okay, that's wonderful. Now, part C. The payment machine gives the customer a ticket when they have paid their parking cost. Each ticket has a 4-digit hexadecimal ticket number that is stored as binary. The binary number, the one huge value given to you, is stored for a customer's ticket number. Now, do not get overwhelmed. We know how to do it. So what we are going to do is, just let me show you what you will do here in the paper also. You will make the patterns like this, 1, 1, 0, 0. Then it will be another pattern that will be made like this. And then you can see here. And just to make you comprehend, 1, 0, 1, 1, then 1, 1, 0, 0, and then 0, 0, 0, and 0, 1, 0, 1. Okay, starting from the right hand side, remember, although exactly right now it's the right, now you can see 4, 4, 4, 4, but be very cautious that always start from the right hand side. Always start making the group of 4 bits from LSB whenever you are given a binary number to be converted to hexadecimal. Exactly, right now this is very simple, but still, if you do not have a question that deals with the multiples of 4 bits, then that might you might land into a problem. That's why suggestion, always start making the group from the right hand side. So same thing is mentioned here just for the color coding so that you can comprehend. So what we did is 1011, the first group, then 1100, the second group, then the third group is 0000, and the fourth group is 0101. Now, by the way, I think we remember, but let's recall. It's 1248, 1248, 1248, 1248. Should I do it or do you remember it? Okay, that's great. 8 plus 2 is 8. Written here, all zeros means a 0. Then you can see 1 and 2. These 2 bits are on. It means a 3. And 8 plus 4 plus 1. 8 plus 4 is 12. 12 plus 1 is 13. And 13 or D. They both mean the same, and definitely you will write D because that is hexadecimal number. That's why it will be A or D or B, C, D, E, F. So the maximum value is F in hexadecimal, as we know. So this is what you wrote here, and your final answer will be written here, hexadecimal number A03D, and this will give you 4 out of 4. See, so easy. Be cautious, and you will be gaining 4 marks. Part D, any questions before we proceed to this next part? Okay. Explain why data input into the payment machine needs to be converted to binary. Like, why is it so? I mean, exactly that you know it very well. It contains logic gates or it contains switches that are only able to process the values 1 and 0 only. Because you remember that they have only 2 states, a 1 or a 0. So that will give you 2 out of 2 if you have actually written the right answer. It contains the switches, and the switches are only able to process 1 or 0 only, or they have 2 states only, an off or an on. In this manner, you will gain 2 out of 2. Okay, now the next part E. When a customer is leaving the car park, they arrive at a barrier. The customer needs to insert their ticket into a system at the barrier. This system reads the ticket number, then checks whether the parking cost has been paid for the car. The barrier is raised if it has been paid. The system uses a microprocessor. Describe the role of the microprocessor in the system and how it checks whether the parking cost has been paid. It's a 4-mark question. So just see scenario is given to you, and they are simply asking us to tell the role, to explain the role of a microprocessor in this whole system. So if you just recall, this is what we have been doing in different ways in different topics. So what will give you the marks? Comparison, comparing the ticket number received to the stored data that is stored in the database, or it is in the file of the ticket numbers. It is going to check that the ticket number is listed as a paid ticket. If the data matches, and or if it is found that the cost is paid, it sends a signal to raise the barrier. If the data does not match or the cost is not paid, then the barrier remains down. So simple. Just see the stages. You have written the points properly, you will be gaining 4 out of 4. Just be cautious. First stage is comparison of the ticket number with the stored value. If the database contains the ticket number, it's able to find the ticket number, then it will be checking that what is the state of the ticket number. Is it paid or unpaid? If paid means the barrier will be raised. And in case that the data shows that it is not paid, it is unpaid, then it means the barrier remains down. So simple. It's all computer microprocessor based, so definitely that will be done faster. Okay, question number 3. The table contains 4 descriptions about a computer system. Complete the table by writing the correct term for each description. Now, first description, a collective term for the physical components of the computer system. See, it's so simple, hardware. Fine. A type of software that provides services that the user requires and allows the user to perform tasks on the computer. See, it's a software that is providing services that the user requires and allows the user to perform tasks on the computer. See, it means that they're expecting me to write the example, like the type of the software, and we know the application software is the right answer. Because it's not going to be the system software exactly. Be very cautious. System and application, these are the 2 types of software. So we have to figure out that which will be the right option to be written here, and is going to be application software. Any issues? Okay, now the third one, a type of software that manages the main functions of the computer, including managing files and managing memory. So these 2 terminologies are actually the complete indication of what it is actually. It's managing files and managing memory management. So this is the task that is performed by the operating system. This is what we have been learning, isn't it? So be cautious. Services that the user requires and allows the user to perform the task on the computer means application software. And on the contrary, another program, that is another software that is needed, like for managing the files or for managing the memory, it is the operating system, the only option available. Isn't it? Easy? Okay. A type of software that is stored in the read-only memory ROM, it includes the basic input-output system or BIOS and the bootloader. The right term for this is firmware. So if you really have learned your terminologies well, you remember them, then you can actually score 4 out of 4 so easily. Isn't it? Okay, now let's move to the next question. 4A. Data is transmitted between a computer and a printer. Part A. The data is transmitted 1 bit at a time down a single wire. 1 bit at a time down a single wire. Now let me highlight so we can recall. And down a single wire. Now, the computer can transmit data to the printer, and the printer can transmit the data to the computer using the same connection. Now, and computer can transmit the data and the printer can transmit. It means they are talking about, now be very clear and circle the 2 data transmission method that will transmit the data in this way. Now, you have to first of all understand 1 bit at a time, 1 single wire means it is going to be definitely serial transmission. And it is going to be, now the computer can transmit data to the printer and the printer can transmit the data to the computer, means it is going to be two-way. And this two-way is going to be either in the same, like for example, it is going to be half duplex or full duplex. So in this manner, you can see serial full duplex the right option and serial half duplex the right option, because it's dealing with just pay attention, and I think it is very easy to comprehend. The two transmission method that are uh, or like talking about the same are serial full duplex and serial half duplex. Not parallel full duplex, not parallel half duplex, not parallel simplex, not even serial simplex, because parallel means multiple wires. That's why, since it is not saying single wire, that's why it is going to be not the right option. So all the parallel are not included. What is left is serial, and with serial, definitely, since it is talking about two-way. So two-way communication means it is going to be your yes, exactly. Two-way communication means it is going to be half duplex or full duplex. Okay. Any issues with comprehending this question a little bit? You need to understand, and then 2 marks are yours. Okay. An odd parity check is used to detect the errors in the data transmission. Explain how the odd parity check how the odd parity check detects the errors. It's a 4-mark question. See, how will you answer? It means that here they're expecting you to explain how did you perform this odd parity checking. So just see, what do we do actually? Whether it's odd parity or even parity, what we do is we are going to count the number of ones. Or in other words, the number of zeros also, but normally we say the number of ones are going to be counted. And you can see a parity bit is added to the byte. Or if you remember vividly, then it's 7 bits before transmission. And it should be counted that the number of ones in each byte should be an odd value. If it's value, it's already odd. After transmission, if the number is odd, no error is detected. But after transmission, if the number is even, then it means the error has been detected and this is not transmitted accurately. So just see, this is what we have learned. We have learned this method, how to calculate the odd parity value. And here we are being asked to explain it, that how did we reach this answer? See, it's so simple. Whatever you do, just put it in your own words and explain it properly. Follow the sequence, what we have done, what we have learned. First of all, we are just going to count the number of ones. If the number of ones is already an odd number, a zero is added there. If the number of ones and the odd parity is being used, if the number of ones is in even value, then a one is added. In the 7 bits exactly. Okay. So just explaining all the 4 points. In the 4 points, you are going to gain 4 out of 4. Okay, now the next part C. Another error detection method sends the data from the computer to the printer. Then a copy of the data received is sent back from the printer to the computer. The two sets of data are compared to see if they match. State the name of this type of error detection method. So same copy sent back to the sender. It means it is going to be your echo check. So simple. Okay, question number 5. Any questions? I hope that you are clear about the explanation of how odd parity has been done. But by the way, if you're facing problem, then there's a video you can watch for your own self, and you can understand what are the detection techniques, and you will be able to understand it also. Okay. Now, question number 5. A musician is recording herself playing the music for a song on the piano. Part A. Explain how the analog sound is recorded and converted to digital. Now, this is a 5-mark question. How can you score 5 out of 5? First thing is you will talk about analog sound is recorded using a microphone. Definitely, I need a device, an input device for the purpose. The sound wave is sampled, measuring the height or the amplitude. Each amplitude has a unique binary value. The sample rate is set. That is the number of sound samples taken per second. The sample resolution is set. That is the number of bits used for each sample. Each sample taken is converted into the binary value. So in this manner, If you have written the proper sequence, if you explained it properly, then you will be getting 5 out of 5. First of all, you talked about the analog sound recorded by using microphone. Then you have talked about the sound wave sampling. Then you have talked about the amplitude. Then you have talked about the sample rate and the sample resolution. And in the end, each sample taken is converted to the binary value. You are through with your answer. Easy? Okay, part B. State two ways that the accuracy of the recording could be increased. How can you improve the accuracy? How can you make it much better? See, increase the sample rate or increase the sample resolution. These are the two ways which are used to uh, improve the accuracy, to make it much better. So simple, isn't it? Okay, part C. The musician compresses the sound file using lossless compression instead of lossy compression. Explain why the musician would choose to use lossless compression instead of lossy. Just think, why is lossless a better option for him? Why? Um, Maybe they want to be able to edit the original sound file. They want the highest sound quality for the file, or they want the sound to be closest to the original one, because they know that using lossy would reduce the sound quality, and they know that using lossy will actually delete the data, some part of the file data permanently. And once the data is removed, it cannot be recovered. I mean, you know it very well that once we have performed the lossy compression, then there's no chance of getting the data back. So that is why, if you have mentioned any 3 points from this discussion, then definitely, if you are able to actually talk about it in the right manner, then 3 marks are yours. Easy till now? Okay, part D. The musicians types the words for the song into a document. 2 character sets that can be used when converting text to digital are the American Standard Code for Information Interchange, or ASCII, and Unicode. Explain the differences between ASCII character set and the Unicode character set. It's a 4-mark question, and how will you score? ASCII is limited, like you know very well. ASCII is limited characters. It is not as vast as Unicode is. Unicode is supporting more characters. If you talk about ASCII covers a limited set of languages, or the lesser languages as compared to Unicode, that is able to support many languages, and even it can support the emojis, which are not supported by ASCII code. Another point that you can write is ASCII requires 7 bits or 8 bits per character, while on the contrary, Unicode requires up to 32 bits or 16 bits of per character. Like, as you remember, 4 bytes exactly. That's wonderful, Ali, that you remember this, that Unicode is able to score the values in 4 bytes. And when you say 4 bytes, means it is 32 bits. Or maybe in some cases, the earlier versions maybe were supporting 16 bits also. So that's why if someone had written 16-bit, then even they had taken that as the right answer. And if you talk about ASCII, ASCII has 128 or 256 characters, while on the contrary, Unicode can support 65536, or if you do not remember, no problem, can simply say approximately 60 to 70,000 characters, or you can even mention 4 billion characters, because if you have talked about 32 bits, then 4 billion characters it can support, and such a huge value. Exactly. ASCII is 7 bits, and extended ASCII character set is 8 bits. That's why we have just written 8 or 7. They both will be accepted as the right answer, because the student has written like 7 or 8 will be acceptable for ASCII value. Understood? Any issues? See, it's so simple. You have learned it. And still, if you have a problem, then again, another video is there for you, and you can watch that video also. Question number 6. Draw and annotate a diagram to demonstrate how a firewall works. It's also a 4-mark question. See what they are expecting you to have in your diagram. Traffic passing both ways through the firewall, because definitely it's a full duplex communication. An indication that criteria set for the firewall. Traffic is compared to the criteria. Traffic being rejected if it does not meet the criteria, or traffic is going to be accepted if it meets the criteria. Now, this is what you can see. Firewall is drawn here in the middle. A computer and the network are drawn on the extreme sides. And here you can see the traffic is traveling. And firewall examines the traffic passing through the firewall against the criteria set. And user is setting the criteria for the firewall. Like it's you who are setting the criteria for your network to be, like for your computer system to be accessing. And any traffic that does not meet the criteria is rejected. And you can see it's drawn here and it's rejection, like it should not be accepted by the computer system because that is not meeting the criteria. So here you can see the traffic is allowed and here the traffic is blocked. The traffic is not allowed. So if you have drawn a simple diagram, you have written written the right terms and you have explained with a simple terminology, like firewall examining the traffic, and it is just going to reject if it's not meeting the criteria. It will accept what the firewall is, like the computer system has the set criteria, and the firewall is going to examine the traffic, rejecting or accepting based on the set criteria. So you will be able to score 4 out of 4. Simple drawing, simple words to express the whole process. Marks are yours. Exactly. We need a little bit practice, and I think we have talked about it when we were doing chapter number 5. I told you that this is what you need to pay attention, that this again can come in the paper, and see, it has come in the paper. Now, complete the statements about question number 7. Complete the statements about data packets and packet switching. Use the terms from the list. Some of the terms in the list will not be used. You should only use a term once. Which are the terms? Destination address, first, footer, header, last, main data, packets, payload, routers, servers, and trailer. Now, there are so many terms, and out of this, some are going to be used and some will not be used. So let's see. Data is broken into packets. As the data is broken down into packets, a data packet has a packet dash that contains a packet number and another blank. A data packet has a packet header that contains a packet number and the destination address. So how did we get it? Yes, exactly. Let's great, Emma, that we know that it is the source, the destination address along with the source address. But right now, since they have not mentioned the word source address, that's why we have only taken the word header from here. Then we have included the word destination address here, and then our marks are 2. We have gained 2 marks. Each packet could take a different path from the sender to the receiver. This is controlled by router, exactly. Packets may arrive out of order. Once the dash packet has arrived, the packets are reordered. One switch packet, definitely the last packet, not the first one. Like when you have received all the packets, then in the end, the packets will be reordered. Any issue? See, it's so simple, isn't it? Okay, now, any issues? No issues? Let's move to the next question. Question number 8. Storage can be described as being magnetic, solid state, or optical. Give 2 features of magnetic store. Magnetic storage, exactly. What is the magnetic? What are the features? Data is stored on platters. Platters are divided into tracks and sectors. It has components that are spun or that are moving at a very high speed. Data is written to or read from using a read-write head. Data is read or written to using electromagnets. Magnetic field determines the binary value. It's non-volatile. So if you have mentioned any 2 features, then you will be getting 2 out of 2. Isn't it easy? Now, part B. Give 3 features of solid-state storage. By the way, this is what we have been discussing, that the few terminology that you need to know about the magnetic store were like the platters, the read-write heads, the tracks and sectors, and how the data is written to the disk is spinning at a very high speed and the data is written on it, isn't it? The binary values are written on it, and basically the magnetic store, if someone wrote magnetic store is non-volatile, then that's will also be giving him the marks. Okay, give 3 features of solid state storage. Any 3 from, it's a 3-mark question. Flashes data onto chips, uses transistors, uses nanotechnology, it uses control gates, it uses flow gates, controls the flow of electrons, it can be volatile or non-volatile. So these are going to give you the 3 out of 3 if you have mentioned any of the values properly. Now, another part C, give one example of each type of storage. Magnetic, what can you write? HDD, magnetic tape, floppy disk, magnetic strip, anything will do for your magnetic media. For solid state, you can say SSD, you can say USB drive, you can say SD card. These all will give you again a mark. Any one will do. Definitely options are written for you. And for optical, a student can write CD or DVD or Blu-ray. Again, he will be scoring a mark for that also. So just recall your learning, write your answer, and marks are yours. It's easy till now. That's great. Wonderful, inshallah. You will be doing well in your papers also, inshallah, and you will be scoring there, inshallah, also. Okay, now the next question. Question number 9. An interrupt is a type of signal that is used in a computer. State the name of the type of software that manages the interrupts. See, it's operating system. Exactly. We have been talking about interrupt handling, or a student can even write interrupt handler. So if you write operating system, perfect. If you even wrote interrupt handler, then that is also a correct option. That will be treated as a correct answer. Okay, now part B. Describe how interrupts are used when a key is pressed on a keyboard. Now, what is happening actually? It's a 5-mark question. So what happens actually the moment you press a key from the keyboard? First thing is, key press generates the interrupt. An interrupt is definitely given a priority. Interrupt is sent to the CPU. Interrupt is placed in a queue, and CPU stops current task to check the queue or to service the interrupt. And definitely it has an ISR, interrupt service routine. And the key press is having the higher priority, the interrupt is processed. Like if the key has a low priority, then interrupt is going to be processed a little later. Exactly like you remember, some interrupts need immediate handling and some interrupts can be the delayed ones. So it will check the interrupt handler will check that what is the priority of the interrupt. If the interrupt is of higher priority, the interrupt will be processed immediately. But in case it is of low priority, then it can be deferred till a certain later time. Okay? Any issues, any problem till now? Okay, now part C. Part C, interrupts can be hardware-based or software-based. A key press is one example of a hardware interrupt. Definitely it's dealing with hardware. Give 2 other examples of a hardware interrupt. Now, just think anything that comes to your mind. Printer out of paper, paper jam in printer, plugging in a device, clicking a mouse button, moving the mouse. Like for example, right now, if I am moving this mouse, this is also generating an interrupt. If I type something here, you can see I'm just giving you an example. I typed 6 here, for example. I deleted. So typing this digit 6 raised the interrupt. Or similarly, if I deleted, again that had raised the interrupt. So this has been happening constantly, moving the mouse, clicking the mouse, plugging in a device, paper jam in a printer, printer out of paper. So any 2 examples are going to give you 2 out of 2 for the hardware interrupt. And then second part is give 2 examples of a software interrupt. So any 2 examples will do, like division by 0. 2 processors accessing the same memory location will again result in an interrupt and a null value. So these are the examples, as you can see here, of the software interrupt. So I hope that we have solved the entire paper 1. That is paper, you can see 0478, November 2023. And I hope that you have enjoyed your learning. If you have enjoyed this paper solving, if you have enjoyed my way of explanation, please share with your friends and family so they all are going to benefit from it. And do not forget to click on the bell icon so that you are getting the latest updates of all the videos as soon as they're uploaded. Take very good care of yourselves. Take care of your siblings, your parents, your friends. Keep learning, keep watching. May Allah bless you. May Allah be with you. Allah Hafiz.